Please subscribe. Please subscribe to Yugandhar PM channel.
Subscribe Yugandhar PM channel. Yugandhar PM YouTube channel.
குட் மார்னிங் சார், குட் மார்னிங் மேடம். ஸோ இப்போ வந்து ஸ்டெம் லேப்பை பற்றி வேர்ல்டு விஷன் நம்ம இன்ஸ்டால் பண்ணியிருக்கோம். ஸோ இதை வந்து சின்னதாக இப்போ நம்ம எப்படி பசங்களுக்கு டீச் பண்ணுறது எவ்வளோ ஈஸியாக நம்ம எல்லாருக்கும் சொல்லிக் கொடுக்கறதுக்காக சச்சின் சார் வந்திருக்காரு. ஸோ இவர் தான் இந்த ஸ்டெம் லேப் வந்து ஃபுல்லாக நம்மளுக்கு இன்ஸ்டால் பண்ணி கொடுத்தாரு. ஸோ அவருக்காக தேங்க்ஸ் சொல்லிக்கலாம். ப்ளஸ் அவர் வந்து நெக்ஸ்ட் வந்து எப்படி கிளாஸ் எடுக்கிறதுன்னு சொல்லிட்டு ஒவ்வொரு பாட்டாக வந்து நம்மளுக்கு சொல்லிக் கொடுக்க போகிறாருங்க. ஸோ ஒரு இன்னைக்கு ஷெட்யூல் வந்து ஒரு 2 o'clock வரையும் நம்ம பிளான் பண்ணி வச்சுருக்கோம். உங்களுக்கு வேறு ஏதாவது டவுட் இருந்துச்சுன்னா ஒவ்வொரு சப்ஜெக்ட்டும் முடிச்சிட்ட அப்புறமா உங்களுக்கு நீங்கள் கிளாரிஃபை பண்ணிக்கோங்க சார் கூட பேசி. தேங்க்யூ. வெல்கம் சார். தேங்க்யூ.
And I'm from Smart Circuits Innovation. So along with the World Vision, we set up this STEM lab in your school. Okay, I hope you all like this lab. Means the way we represent each and everything here. Okay, models, the detail about models and the doodles and everything. Means whatever we put here, I hope you all like these things. You all like now? Okay. So I'm very thankful to World Vision India and the school so that you give us the opportunity to set up this particular STEM lab in your location, in your school. So this particular STEM lab is really, really important for students. So what is our agenda behind setting up this particular lab? So the main thing is, you all know students are teaching lots of theoretical concepts in a notebooks, in English, sorry, in science, in mathematics, in everything. So our main motive is to deliver them the practical education. Okay, because the thing is, if I am taking an example, we all watch movies. Okay, so if suppose, if I'm just taking example of any of the movie, suppose there is a movie, any movie, XYZ movie. So if we give 400 500 pages of a book related to that particular movie to the students, so I hope students will not be indulged in that particular reading skills. Okay, but when they watch movie now, in that particular, what happens is they are actually watching the practical of that particular theoretical part. Okay, so if they are watching the practical part of that particular novel or any of the story once, twice, thrice, then once in a while the time comes when students or any one of us, we remember the scenes, we remembers the dialogues also, like after this particular dialogue, actor or villain will do this thing and this thing. Same happens with the practical also. See, if we are teaching students any theoretical part, okay, so then they need to cram it actually. Okay, but related to the some particular topic, if they will do the practical thing, they will do the experiment, then what happens is they are able to remember the things because they have done the experiment with their hands. You all agree with me or not? I'm right now. So that's why, keeping that thing in mind, we are here for the this particular, we are here with this particular STEM lab. And in this particular STEM lab we installed 80 models. Although more than 80 models are there, approximately 1993 models are there. Okay, but the sanctioned models are 80. Apart from 80 models, whatever we feel these are also the important topics, we include in this particular lab. Okay, all these models are related to physics, biology, some of the electronics part also, like in 6th class or in 7th class or in 8th class, in state boards or in other boards, there are topics related to bulb, open circuit, closed circuit, conductors, insulators. Okay, so these concepts we covered here in this particular STEM lab, and along with that followed by physics, biology, then we also have some of the mathematics experiments also, the stuff related to mathematics part also. Okay, so this all is about this lab. So we need one favor from all of you teachers. So whenever you teach any concept, any topic in a class, and if you find any of the topic is having the material here, so there are two ways to give the practical knowledge to the students. One is you take all the students to this lab and then you just explain them particular topic. Or another way is, another innovative way, you just take the material to the class. Okay, you just explain the model, principle behind that model, what is a working principle. And another important thing, try to correlate that particular model with the daily example. Okay, that is an important thing, because here I'm just giving an example to you, means how you will be able to correlate all the topics, means maximum topics, with the day-to-day life. So there are some experiments which we gave here related to mirror. Mirror means, we every day when we came to school or we go anywhere, we just saw the mirror and just comb our hairs and check ourselves like whether our clothes are okay or not. So when we are giving mirror here, so how you correlate this particular thing? You just ask student, what is the difference between a glass and a mirror? So if you ask questions na, then they start thinking. Some of the students will say yes, both are the same things, but yes, there are some students who tell you like glass is different thing and mirror is a different thing. So then you just take the example, glass is a transparent object from where we will see, means if I am having a glass, so in between glass I am able to see the thing which is at the back side of it. But in case of a mirror is a reflecting object. Okay, then you ask them, are we able to make mirror from a glass? Yes, it's possible. If we do a polish at a backside of a glass, we will obtain a mirror. How many types of mirrors are there in day-to-day life? All can we use all these mirrors? Yes, we use all these mirrors. Where we use all these mirrors? So in this way, if you will take a question answer, if you ask the questions from the students, then they also involve in the practical part, and they also insist like, yes, I need to think. And if possible, give some task from their home, any of the tasks, like we are having periscope here, we are having Newton disk here in our lab. So while explaining Newton disk in a class, give them homework. Take a round paper, take 7 colors and draw the Newton disk. Okay, and if you rotate it, just observe what will happen. And what is a practical example of Newton disk in day-to-day life? Are we able to see the Vibgyor pattern anywhere? So in this way, students will be able to involve. Okay, so it's all depend on you how you involve the students. Okay, so we are having couple of things here. Although you all are aware, you all are experts in your subjects, I know that. See, but still I am here to just brushen up the things and to explain in detail like how to use the particular apparatus to explain the things. Although you all know more than me, I'm pretty sure I know that thing. You all are experts in your subjects. Okay, but yes, my only motive is to explain you the particular working of that particular apparatus, means how to use this apparatus. And yes, with the maximum of the things I'll try to correlate it with a practical example. Means out of 80 I'll try to correlate 20-30 things with the practical example, so that you also know how to explain the things to the students in a practical way. Okay, so any doubt, any question till now if you are having, means what are there in a lab and anything? I think you all are aware, probably you have visited the labs also. Okay, so to make this lab innovative, what we have done, along with the material, we have not given material, but yes, we also give the detailed backdrops of this. These backdrops contains the picture of a model. Okay, what is the principle behind that particular model, and somewhere we also written the important concepts of that particular apparatus. Okay, then so that our main motive is to, like, when anyone came to this lab now, there should be a feel inside the lab, and we do innovative things. How? Means one of the example is like in 10th class we are having the periodic table. Okay, so what we have done here, we took some words actually, like here you are able to see ambition. So ambition is although having some meaning, some Hindi meaning or in Tamil meaning, in day-to-day life there is a meaning, like some any of the person is having ambition to become doctor, engineer, anything. So how we correlate it? We took some words of the periodic table, if you are able to see. For ambition, AM americium 95 number. Okay, Bi bismuth 83 number. Okay, Ti titanium 22 number. So in this way, some innovative, means whatever innovation is possible now, so that we try to do here. Okay, in a similar way, science word is there. It's a STEM lab. Maximum concept of science is there. So we took the science word. All these words, if you are able to see, these are from the periodic table actually. Inspire is also here. You will see universe. So all these words, all these alphabets, all these things we have taken from the periodic table. Okay, and then to make it beautiful, we use these type of doodles also. And if you are able to see these doodles, these are not the simple one, these are also related to the subject. Like if I am talking about this is somewhere a Newton's cradle. This is a doodle of Newton's cradle. This is a flask. This is microscope, globe. Okay, so in this way, this is some chemistry, CH3. Okay, CH3 bond is there. So this is a pulley. So this is another thing. So this is compass, flask. So in this way, we try to take maximum things related to the subject only, so that if students came in this lab, so they should have a feel. And another important thing, out of some of the schools, see, your school got the opportunity to get this particular lab, so it's all depends on you how you will able to use this lab and take the maximized output from this particular lab. Okay, because at our time now, definitely you are uh, satisfied with whatever I am saying. In our time, when we were in school, we don't get these type of opportunities. Okay, so study the practical things. But yes, if lab is there in your school, try to take maximize output from this particular lab. Okay, so shall we start with the training part? Okay, so you all are comfortable with my English, or I'll call ma'am also, so that she will explain in Tamil whatever. Okay, so if you require, then ma'am is there, you just ask. Okay, ma'am. Okay, na sir? One by one, I'll take all the apparatuses, all the projects, and we will just do turn by turn. So the very first apparatus which I am taking is this one, a magnet topic. Okay. So see, ma'am, I need one blank paper. Now we are having couple of things here. So the very first thing is we are having this bar magnet. Okay. So whenever you show any of the thing to the students, please ask them questions like what is a magnet? What is the use of the magnet? In day-to-day life, where you will see the magnet? Okay. So right now you just means which type of magnet is this? Okay. This is a bar magnet. Okay. How many poles this magnet is having? Magnet is having two poles, north pole and the south pole. See, right now it's not written here which is a north pole and which is a south pole. Okay, but yes, we know same poles repel each other and opposite poles attract each other. So first of all, we will try to just check it out. Okay, so right now, if I am putting this magnet here, so this is repelling. So that means these two poles are same. Okay, and if I'll use these two poles, these are also repelling, means these are the same poles, either these are north poles or the south poles. Okay, then you ask students like how we will be able to know what is a north pole, or means which one is north pole and which one is south pole. In some of the bar magnets na, it's written N and S, but here if you will be able to see, there is a dot. So this dot denotes the north pole. Okay, so this is a north pole and this is also a north pole. So same poles repel each other. Okay, this is a first concept. Then you ask them, is magnet attract or repel only a magnet or any other thing also? Okay, this can be a second question. So for this we are giving the metal things. So magnets always attracts the metal part. So in this way, these metal parts attract to the magnet. Okay, then this can be your second thing. Then how many types of a magnets are there? Because it's not like we are having only the bar magnet. So we are having different types of a magnet. And another important thing, if we break this magnet from center, then this particular magnet breaks into two parts, na? Then again this magnet attains the poles with itself. If you break it from here, then this is a north pole, then this becomes the south pole, north pole. Means again it will attain the poles. This is a property of a magnet. And another important thing, like how many types of magnets are there. So here we are giving you couple of magnets, like this is a U-shaped magnet. So in this U-type magnet, these are the poles. Okay, and another type of magnets are these magnets. These are the disk magnets. Okay, see, these are the same poles and these are the opposite poles. Right now, that's why it's repelling. Okay, so where we use these type of magnets? In speakers. In speakers we use these type of magnet, these disc magnets. These are the ring magnets. Okay, in this particular ring magnet, where we are having the poles, inside we are having poles, and upper and lower side also we are having poles. So just to check it out, see, means these are the opposite poles. If I flip it this way, now this is attracting, means these are the same poles. Okay, and then in all the books, means whatever publishing book you are using, so there is different type of a magnets. Okay, then in each and every textbook whatever you are following now, there is a concept of magnetic lines actually. Okay, magnetic lines. So everywhere, means every time when we ask for the magnetic lines, normally what we did, can I use this paper, or I can had a things in our mind like bar magnet. So there is a thing called magnetic lines. Okay, so how we explain magnetic lines to students? Normally we said there is a bar magnet. Okay, it is having a north pole and a south pole. So there are imaginary lines like this. From north to south, it originates from north and it ends at south. So in this way we are having a magnetic lines, and at poles we are having a maximum magnetic field. Am I right? So see, when we don't have the apparatus or anything in our hand, then it's fine to explain these things to students. Okay, and students will also like cram, or they fit it in their mind like yes, magnetic fields are there. But now here, if we are having this particular STEM lab, we will actually see like, is it possible like these type of STEM, these type of magnetic lines are there or not? That is an important thing, na? Like, see, we also studied at a time when we were in school, like magnetic lines are there. These are the imaginary lines, magnetic lines are there. But see, frankly speaking, I am also not aware, like in actual, is there any magnetic line or not? Okay, to check this out, what we, sorry, yeah. So what we did here, this is a bar magnet. So I put bar magnet here and I put a paper on it. Okay. And now, see here it's a bar magnet. What I will do, we have given you this iron filings, the powder.
Iron powder.
Yeah. This is the iron powder, sir. Yeah. So
இரும்பு தூள் இருக்கும்ல சார், அது போட்டோம்னா அதே மாதிரி ஷேப்ல வந்துரும். இப்போ அவர் வரைஞ்சார்ல அதே ஷேப் இதுல வந்துரும். அந்த லைன்ஸ் அப்படியே வரும்.
So I spread these particular iron filings over the magnet.
நமக்கு அப்படியே கொட்டினா அது தெரியாது, அது நம்ம கொஞ்சம் கொஞ்சமா கொட்டணும், ஏன்னா அப்பதான் அந்த மேக்னெட்டிக் ஃபீல்ட்ல வந்து அந்த ஃபார்ம் ஆகும். இப்போ அவர் வரைஞ்சார்ல அதே மாதிரி.
See, and then what I need to do is I need to tap on a paper. I spread the magnetic these powder, iron filling powder. See, so in this way, see, lines are there, na? See, start from here, originate here, and here we are having maximum, and we said na ki at poles we are having maximum magnetic field. So see, here you are having maximum of this iron filling powder. Okay, so in this way, means when any student did it with their hand practically, or you showed them like these type of, see, you just ask them like these magnetic lines, we are not saying these are the lines, these are the actually imaginary lines, but we are not saying you just not check these lines, like whether these lines are there or not, whether these lines lies or not. So with the help of this experiment you will be able to see. So now magnetic lines are there, and again means you need to tap it very slowly. See, so much of fine magnetic lines are there. Sorry.
சமத்துக்கு sign போடுவீங்க.
Students will be able to see the magnetic line. So this is a practical example. Okay, and each and everything in our lab that is reusable, that is important thing. So what you will do, you just take the paper, okay, take this and put it here. Means nothing will be wasted. Close it, put it here.
Iron powder.
Iron powder, yes.
நம்ம இரும்பு
Very,
தூள்
very fine iron powder. And we have given.
These lines of increase or decrease in magnetic field.
Hmm.
இந்த லைன் வந்து எப்படி சொல்றது சொல்லட்டுங்களா? These lines are increase for the magnetic power or
Yeah, it all depends on a magnet, how much power it is having. So if I take the magnet of much power, then the more lines will be there. But yes, this is for the.
some students ask, ma'am, this is only 3 lines only.
No. See, if you will just see the practically, there are approximately 12-15 lines. This is though we draw now only 3 lines. It all depends on, see, if you make the bigger magnet this way.
So depend on the magnet.
So then you will be able to make more lines.
அந்த மேக்னெட்டை பொறுத்து நமக்கு அந்த லைன்ஸ் வந்து இன்க்ரீஸ் ஆகும்.
And on the paper also, na, when I draw, when I fold these, understand.
So,
Yeah. See, curiosity must be there in a student to ask a questions. That is our main motive also. Like if students involve in these particular things, na, if they are understanding, only then they will be able to ask question from you. If they are not enjoying, na, they will not ask any question. That is an important thing. Yes.
some students, ma'am, why are you only 3 lines?
Yes. Yes.
அந்த மேக்னெட் பொறுத்து அந்த
To explain the magnetic lines, we are having one more experiment. Okay, so here what we have done, inside this particular chamber we are having a liquid. These are the iron fillings, if you will be able to see. Okay, and inside this I am having a magnet in this.
அதுக்குள்ள வந்து மேக்னெட் போட்டுருக்காங்க. அதை சுத்தி என்னன்னா இரும்பு.
So you can take it.
இப்போ நம்ம எடுத்துட்டோம்னா அந்த மேக்னெட் வந்து
See, if I take the magnet na, right now, to see what happens to this. This will settle down at the bottom right now. Yeah, right now to it settled down because we don't have any magnet.
they are not magnets.
Yeah, no magnet is there.
Just iron powder.
Only iron powder in a liquid. Okay, but yes, if I put a magnet here, see now what happened. The magnetic lines which we have made there, now you will be able to see these magnetic lines here also. See,
அந்த நார்தன் போலுக்கு அங்க வந்து
here also magnetic lines are there, and these are the poles, this one and this one, maximum magnetic lines, because maximum power is there. So right now these are the magnetic lines.
சவுதர்ன் நார்த் போல்.
Okay, na?
That's iron powder.
Magnetic lines again. So to explain these magnetic lines, you will be
only paper la மட்டுமே பண்ணாம all liquid paper not only also liquid la பாக்கணும்.
Poles la magnetic field is
maximum magnetic
At
field
poles.
at poles. That's why if you will be able to see, iron filings here maximum, here maximum. In between there are only magnetic lines. See, and it all depends on
power of magnet.
Again. So that's why we put 2 magnets here. See, these are 2 very big magnets, so we put it here. So these 2 experiments will explain, means what is a magnet, what is a magnetic field, how magnetic field forms actually. That is another important thing, means how magnetic field forms. Okay,
Maximum at the poles.
maximum at the poles. This is this is with any magnet, means any magnet is there, then magnetic field is maximum at the poles. This is an important thing.
அது யூஸ் கவர் இருந்துச்சுன்னா அதுவும்
Next concept we will cover, that is of mirror.
என்ன மாதிரியான டைப்ஸ் இருக்கு, அதுல என்ன மாதிரியான ரிஃப்ளெக்ஷன் நடக்கும்ன்றது.
So to explain,
magnet loses power.
sir, if we heat the magnet, see, to explain this na, we are having bar magnet, so use one candle, okay, and just put one end of a pole with on the candle while burn it, okay. In that particular case the magnet loses its power.
Just drop, not loses.
Yeah, and then when it lowers down, when it cools down, again it will attain the power, okay. We will cover that is of a mirror, okay. So important thing whenever you teach about the mirror, okay, first, like I told you earlier, ask them what is a difference between a glass and a mirror. Glass means a transparent one, which we use on a windows and everywhere, na, that is a glass. Yeah, transparent thing.
Mirror reflects.
Yeah, mirror reflects. Transparent thing allows the light to pass through it, that is a glass. Basic definition. Then ask them how to make a mirror with the glass. How to make a mirror with the glass. Glass. Okay, this transparent glass. This allows, see, if I am seeing this, I am able to see this inside it. But this is a mirror. If I want to see it, I am not able to see. Okay, na? So this is a difference between a glass and a mirror. Okay. Then if we want to make it a glass, is it possible? Then some students will say yes, some students will say no. Then just ask them why. If you are saying yes, then why? Or and how it's possible. So in books also it's written, if we do a coating here, okay, with the help of a coating, yeah, the coating will be able to convert glass into a mirror. This mirrors, na, earlier these were the glasses only. After this coating only, this becomes a reflecting surface, okay.
Light rays
Yeah,
reflects.
yeah, possibly na,
இல்லைன்னா ஏ ஆகும், பாஸ் ஆகும், இது வந்து ரிஃப்ளெக்ட் ஆகும்.
Reflect.
yeah, possibly if you are having any old mirror at your home, so just saw them, there are couple of dots, or somewhere it's a like it's a spot where that particular paint comes out and we are not able to get a reflecting surface. So this happens actually in the old type of mirrors. If you are having at your homes or anywhere, just check those mirrors also, okay. So in this way this particular mirror changes to glass. Next question, how many types of mirrors are there? Another question. There are basically three types of mirror. One is this plane mirror. This is a plane mirror which we are having at our homes also. That is a plane mirror. Another is a convex mirror. Convex mirror, see, means each and everything na we try to give it in an innovative way. If you are able to see this, this doesn't mean it's broken. We have given this type of a mirror. This is a flexible mirror. This is a actually plane mirror, but we convert it into a convex mirror like this. It doesn't mean it's broken. Why I am explaining you. In sometimes what happens na, this mirror comes out and you will just think that this breaks. This is not broken. We have given it in such a way so that you will be able to explain the difference to the students. Right now this is a shapes about a. So right now this is a convex mirror. Convex mirror, the reflecting surface is in this way, okay. And this is a concave mirror, means reflecting surface in a inside. So to remember this, just tell the students like what is a cave. Cave means, you know na, where lion lives, it's inside na. So this is inside reflecting surface, that is a concave mirror. So this is to remember, like how you just correlate the things to remember the names actually. So this is a plane mirror, this is a convex mirror, and this is a concave mirror.
Where it is?
Just telling you, we are wait. So then next question means how these three mirrors are differentiated actually. Okay, so very first thing is in plane mirror. These plane mirrors we use at our homes actually. So what is this? In these plane mirrors, na, we see means we are an object, and inside the mirror there is an image. So object size and image size, these are same, equal. See, if we see in front of the mirror while combing our hairs and everything, our shape is same as that of our, means image shape is same as of ours. And another important thing, if any object is at 10 centimeter in front of this mirror, image is also 10 centimeter behind. Understand? Na? Two important things. One is we are having same size of our image as that of our object. If this pencil is 6 centimeter long in height, then inside also it's 6 centimeter.
Indicating real reflection of both
Same. Means size is same. Means if this distance d1 is 10 centimeter, then inside this the distance of image is also 10 centimeter. There are couple of experiments to understand this, like whether this difference is same or not. Okay, but that experiments is not here included. But yes, we have couple of experiments for that also. But right now, to inform the student, this is enough. Like the size of object and image is same, okay, and distance is also same. This is first thing, okay. This is in case of a plane mirror. And practically where we use the plane mirrors, everywhere we use the plane mirror, in our homes also, in saloons, in washrooms, everywhere there is a plane mirror always. First thing. Second thing, this is a convex mirror. Outwards, na, convex mirror. So where we use the convex mirror, first of all, what is the property of convex mirror? In case of plane mirror, I told you, na, like the size is same. In case of plane mirror, size and distance is same, but in convex mirror, size is smaller and distance is greater.
increase ஆகும் இதுல வந்து size வந்து
Image distance greater.
அதோட distance வந்து increase ஆகும் இப்போ கிட்டக்க இருக்கிற தூரமா நம்ம பாக்குறோம்ல அந்த மாதிரி
Practically now students will ask, so where we use the convex mirror? Practically if there is convex mirror, then might be possible na we used it somewhere. Then practically we used it in a vehicles, the side mirrors of any of the vehicle, either it's Activa, bike, car, truck, anything is there, the side mirrors are convex mirror always. So that's why na one line is also there on a mirror. If you observe, objects in the mirror are closer than they appear. Matlab, what does that mean? That means in actual objects are closer, but in mirror it appears to be smaller and at a distance, because at side mirrors na we want to see too far, so that's why we use this convex mirror. Understand? You know the difference. Third is concave mirror. Now what is concave mirror and where we use it? Concave mirror is this one. Sorry.
satellite type is used this mirror
Yeah, there also we use, but in day-to-day life, where we use these things. See, if I'm talking about this concave mirror, property of concave mirror is image is at a less distance and bigger image and at a less distance, small image and a larger distance. Here bigger image and at a smaller distance. Practical example, then dentists use this type of mirrors. Okay, when we go to dentist na, they watch our inside tooths and all, so they are having very small mirror. They take it with a plucker or anything, they put it inside our mouth to see the whether there is any germs or there is any insect in our teeth and all. So they use concave mirror because they will get the enlarged image. Watch also, yes, watch also. In watch, but in watch na there is not mirror, that is lens, concave lens, that is. Right now we're talking about mirrors. Understand na? So that means if you want to explain about the mirror, so you will explain all these things in a detail to them. Like three types of mirrors are there: plane mirror, concave mirror, convex mirror, differences also, and practically where you are using it. That is another important thing, because see, it's not possible like each and every child or each and every human being so anywhere means somehow went to dentist. It's not possible. But yes, each and every person is having any vehicle at their home, so side mirrors are always there. So those are the convex mirrors, and there is line also which denotes like in mirror size is small, but in actual size is larger, and in this mirror it is showing at a great distance, but it's actually at a small distance. That's why that line is there. Objects in the mirror are closer than they appear. Understand na, sir? So means in this way na, you just involve the students, because it's important, like students should not get bored actually when you are explaining the practical things na. If they get bored in a practical also, then what is the use of practical? Then in that particular case of theory and practical is the same thing. Okay, so that's why we are having the practical things. Okay na. So another important things related to this particular mirror is number of images. Okay, so explain that thing. We are having this particular answer from the time to time. Please ask whatever the means your utility staff or anyone to make it clean actually. Otherwise na, if dust is there on the material and all, then you are not enjoying doing the practicals and all. Images formed. Okay, so for that there is a formula actually. Okay, the formula is number of images is equals to 360 degree upon angle theta minus 1. That is an important formula. Okay, so in our backdrop also we have mentioned that particular formula. Okay, so now what does that mean? If we put two mirrors at a certain angle, then how many number of images it will form? So first of all, what I will do, first of all, yeah, no sir, no, wait, there is a concept actually. See, first of all, we put two mirrors at a 60 degree. First of all, we put it on a 60 degree. Now, if it's possible, now just take 2-3 blank papers, so that wherever possible, I will. These are enough. Just call the ma'am. Just call the ma'am now. She will come. So right now, if you will able to see, one mirror is at 120 degree and another is at 60 degree. That means angle between these mirror is 60 degree. So first case is theta equals to 60 degree. Okay, we'll put the formula here. So right now, number of images 360 degree, 60 degree minus 1. This becomes 6 minus 1. That means total images will be 5. So just check it out. What I will do, at a center I put this pen. So first of all, sir, you observe. There will be 5 images of this. Just see, just check it from here. Center. There are 5 images of this pen. Just see from here.
Oh, 1, 2. Wait. Okay.
பென் கிட்ட இருந்து பாருங்க.
Wait. Now you will be able to see clearly.
1,
See.
2, 3, 4,
1,
5. Okay, sir.
5 images,
1,
na?
2, 3, 4, 5.
5 na?
5.
See, with this particular formula, this is cross check. Means there is not 4 image, not 6 image, not 7. You put in a formula. No approximate, exact 5 image.
Exactly
just-
the 5 image
Yes.
is
You just check it out.
1, 2, 3, 4.
This is the object.
No.
2 here,
2,
2 here, 1 here.
1.
At a center. Okay na? So that means
Some
we,
handles are changed.
yeah, we'll do that. Wait. Understand na? Right now the first case is 60 degree.
5 letters.
You need to put in a formula only. No need to just remember it. Just remember this formula. Okay. So now what we will do next, second case, we will do theta as a 90 degree.
90 degree.
Okay. Now
360 degree by 90 minus 1.
now 3 images.
3 images.
We just cross check whether this particular formula is right or not. But we will do 60 degree na. I increase 15 degree here and 15 degree here. See, right now these two mirrors is at 90 degree with each other. Right now 90 degree na angle. Now I put it here. Now just check, sir, how many images are there. Just cross check. No 6.
2, 3. Exactly.
Exactly 3 na.
3.
Okay na, sir.
Okay.
So this is a practical example, like to understand how many number of images will form if we put 2 mirrors at a certain angle.
What is this? This is mirror.
This is also a mirror just to support, sir.
Support surface.
So, and one more case is left actually. That's why I put this mirror here. Wait, I'll explain you. Now students will ask from you, sir, what is a practical example of this? Means where we are seeing the mirrors at an angle. It's see, in a daily life we are not able to see this, but yes, it related to the practical day-to-day life. We all go to saloon. Men's go to saloon, women's parlor, and everywhere. So there one case is there. We are having one mirror at a front, one mirror at a back. No. Straight mirror, plain mirror. One at a front, one at a back. So if you closely observe na, these two mirrors at how much angle? Just think it over. 0 degree angle na. So that means this is a third case. If theta equals to 0 degree,
360 degree by
number of images will be, it becomes
1.
infinity. Infinity minus 1 and infinity minus 1 becomes infinity. Then it's a practical example. If you will check it in a saloon na, if you just see in front of the mirror, you will be able to see n number of images of yours. So this is a practical example. Means if you correlate the things practically na, then students will also, whenever they will go to the saloon next time, they 100% they will check it out. Like sir informed us, if there are 2 mirrors, we are able to see infinite number of images. We just cross check like whether it's exists or not. So in this way we need to correlate the things to the day-to-day life. So to explain that particular concept, what I will do, this mirror is at 0 degree. So if I put one more, if I put one more mirror here and I cross check it from here. Infinite number of images. Thank you, ma'am.
Infinite number of images.
Infinite number of images are there. So that is a practical example. If we go to saloons, theta is 0 degree. 360 degree by 0 minus 1, infinite number of images. Understand, na, sir? So that's why means we have given all these things here so that you will be able to perform the practical part. So earlier we put it at a 120 degree. This is at a 60 degree. So right now that is the first case. Theta equal to 60 degree. Okay. And if I put it here, I put it here 360 by 66 minus 1, that means 5 images. So if you will be able to see in center 5 images. Cross check.
5 images only.
Now if we change the angle
90 degrees.
to 90 degree,
But it's 90 degrees.
now there are 3 images because 360 by 94, 4 minus 1, 3. 3 images. 3 na?
3 images.
3 images. One object means object is having 3 images. MC, right now there are 3 images. Okay. And it's not like you will use only these 2 cases. You can use any case. If you make it at a 120 degree right now, here 120 degree. Now put it in this particular formula. That is a case number 4.
130 minus 1.
360 degree, 120 degree minus 1, 2 images.
2 images.
Okay, cross check it, sir.
Okay, sir. 2 images only.
Only 2 images. Means each and everything na we explained in a practical way. So that is important. Okay, and to explain means one case also we take 0 degree. 0 degree means infinite. In a saloon, in a parlor, there are 1 mirror at front and 1 at a back. So if we see our image, we will see n number of images of ours. Okay. To explain this n number of images, there is one more experiment in this lab. You just sit it down, I'll just show you. So here what we have done, 1 mirror at our front means back side, and this one is a glass. This is also work as a reflecting surface. So when I put its light here, see infinite number of images are there. Okay, na? So this is another example of this particular infinite number of images. Okay. Next thing is we are having this periscope. Okay. This is also related to the reflecting surface. Here, this is a topic in class 6 actually. In class 6, when you have a chapter of either in 6, either in 7, mirror chapter is there. So there they are having a practical example like in submarines. Submarines is inside under the water. So if they want to see outside the water for surveillance, for security, means what they should use. So practically they are using the periscope there. Means in today's time also practically they are using the periscope. So what is the principle behind this particular periscope? Again, the principle of reflection. But here how we will do in this particular corner mirror means, or in number of images, multiple images topic, we saw we put mirrors at a different angles, then different type of images are there. Here we put angle at a 45 degree. 45 degree this, 45 degree this. So what happens is if I took any object in front of it, so this object is having image on this particular mirror. This mirror is at a 45 degree. Again inside this particular tube, this image falls on this mirror. This is again at 45 degree. And if we see from here na, whatever object is in front of this, we are able to see. You just cross check. And another important thing, if I am watching from here, I will be able to rotate it 360 degree anywhere. Means right now I am able to see the backside of which is written over the blackboard also. So this is the practical example, means in submarines, in actual they are using this particular periscope. This part is inside the submarine and this is outside of the water. Okay, so in practically also in books there is a diagram, they are showing the water and that much part they are showing outside the water. But in today's type of a submarine, it's actually electrically operated. Once submarine goes down, they just push the switch and this length becomes bigger and it comes outside the water. If you will be able to just check it out, you just see from here, whatever is in here, you will be able to see. Just check it out.
அது நீங்க ஒழுங்கா தூரத்துல நம்ம பாக்குறது வந்து 45 டிகிரிஸ்ல வந்து நமக்கு தெரியும். நம்ம 360 டிகிரி இருக்கும்போது 40 டிகிரில காட்டுற ரிஃப்ளெக்ட் வந்து நமக்கு கீழ நம்ம கண்ணுக்கு தெரியும். இது நம்ம exactly 45 degree.
Yes, exactly 45 degree. Ma'am, will you please just check it out. Show it to ma'am also.
இந்த கண்ணாடி இப்படி வச்சிருப்பாங்க சார், ஆப்போசிட்ல இப்படி இருக்கும். அப்ப 45 டிகிரி அந்த லைட் வந்து பார்த்து.
Yes, 45 degree. So now to involve the students, first of all you show this to the students, then ask them take a small mirrors and waste cardboard is there in a home normally, like old books are there or if any appliance they will take from a market, so their cardboard is there. So just ask them to make it a square like this. Means what they need to do is they need to make a structure like this of a cardboard and put one mirror here, one mirror here. If you will ask them na, you just make Z type structure like this, put one mirror here at 45 degree, one mirror here at 45 degree. So whatever object is there in front of this, you will be able to see it from here. So in this way, you will ask them to make the things practically. Now, what is the benefit of this? If you ask student to make periscope, suppose in class there are 30 students, 4 5 definitely they will come with a periscope. So in a year na, at the end of a year, you just have the exhibition of that things.
Same
like
size of image.
same size of image, because plane mirrors are there na sir. Plane mirrors are there, so same size of a image. Not convex mirror, not concave mirror, we are using the same type of a mirror. Understand na? So in this way, this is another practical concept of reflection, periscope. Another thing, we are having a kaleidoscope. Kaleidoscope. So here what happens is, yeah, multiple images. Here also we are having 3 mirrors, but all mirrors are at a 60 degree angle. Means
45 degree, the 60.
they are making a triangle like this. Means we are having 3 mirrors
In triangle.
at 60 degree and we just cover it in a circular tube. So right now, if we see from, and we put a beads in this, so if you just rotate it na, you will be able to see very beautiful patterns.
Same patterns.
Yeah, different patterns.
நிறைய patterns தெரியுது, ஒரு கலர் கலரா. இது வந்து triangle மாதிரி பண்ணாதான் அந்த dimensions தெரியும், multiple angles தெரியும். மிரர் நம்ம plane mirror ஒண்ணு வாங்குறோம்ல சார், இது மாதிரி வாங்குறோம்னா இது வந்து நம்ம இந்த மாதிரி அதெல்லாம் வாங்குறோம்ல, அது ஒரு சைஸ் வாங்குறோம். இந்த பக்கத்துலயே நம்ம ஒரே triangle பொசிஷன் இந்த மாதிரி
related to a different type of objects, and do all object forms shadow or not. So to explain that particular concept, we are having this type of apparatus. Okay, so here what we are doing, we use different type of objects: transparent, translucent, opaque object. These are reflecting surface. Okay, so to check it out, like which object allows how much of a light to pass through it, means in particular object how much light passes, this we can explain with the help of this particular operator. I think this is in class 6th or in 7th maximum. So here if you will be able to see, this is a transparent glass, so you will be able to see what is at a backside. This is a translucent. Translucent means it doesn't allow fully light to pass through it and doesn't blocks the full light. It's a partial thing. It allows us to see at some extent. So this is a transparent, translucent. This is an opaque object. Opaque object means we are not able to see anything. Like wall is a opaque object. Glasses in a windows, that is a transparent object, and these type of glasses na, these are the translucent glasses. Okay, and this is a reflecting surface, mirrors. Okay, so to explain this thing, see, if I on it, this transparent light allows light to pass through it. This is a transparent, this is translucent, so it doesn't allow full light to pass through it. Partial light.
அது வந்து ஃபுல்லா லைட் வந்து ரிஃப்ளெக்ட் ஆகும். இதுல வந்து கொஞ்சமா போகும்.
See, not a full light is passing through it. See, see, little bit of light only, and then there is a opaque object. It doesn't allow any light to pass through it. Transparent object, translucent object, not the complete light, opaque object, no light. This is a reflecting surface. This is not allowing the light to pass through it, but it reflects the light at a certain angle, which is angle of incidence equals to angle of reflection. Opposite words. See, refraction cylinder. If water is there and you checked it from back, na, these alphabets gets reversed. This is an example of refraction actually. Because this is one medium, this is another medium, water. Then we watch it from here, that is again a change of medium. So there is, means this refraction cylinder or these arrows sides gets changed actually. So this
ambulance இருக்கு சார்.
yeah, ambulance is example of reflection, ma'am.
அந்த மாதிரி
Reflection in mirror.
That is in mirror, ma'am.
அது மிரர், இது வந்து வாட்டரா?
No, this is a example of refraction.
Refraction.
That is to na mirror. Ambulance is example of reflection actually.
Reflection in mirrors.
இல்ல ஆம்புலன்ஸ் வந்து தலைகீழா இருக்கும்ல, சோ அதோட மீனிங்.
Plain mirror.
I am not putting it with a very power, so that after doing the experiment now I'll take the water out. Okay, see, see, right now this arrow is at this side, but inside this you will be able to see it in this direction. Check.
லெஃப்ட் சைடு இருக்கு.
All the arrows sides gets changed.
Light refraction.
Refraction. One medium, this medium to this medium to again this medium. Air to water, water to again air. Yeah. Change of medium is there, na? So that's it. And this reflection cylinder, this also you will be able to see in a similar way. You need to just focus it, like till where you will be able to see the exact thing. Okay, so in this way this refraction cylinder works. This is one example of refraction. Another example is we are having with the help of this glass slab. See what happens here is the pencil. See, see, it will show like just make water in means half water, then put till the bottom. Then you will be able to see the bending. Just give me 1 minute. See, ma'am. Yeah. Yeah. See, this is one medium, na? Water. The object is actually na water. We are watching it from a air. So that's why. Refraction. This is example of refraction again. Okay. Of some great personalities also, like scientists and all.
Have water instead of water, oil. Oil.
See, it all depends on a density of a liquid. How means the result is in that means there is a refraction, but in water there is maximum refraction, clear refraction. In oil you will be not able to see the clear refraction and that much of a refraction.
வாட்டர் வந்து அப்படி இருக்காது. அது வந்து நியூட்ரலா இருக்கும் வாட்டர், பட் ஆயில் வந்து கிளியரா தெரியும்.
Sir, from time to time, na, just ask the peons and everyone to just clean the lab, please. So here, if we put glass slab, okay. Now, how refraction happens? How we will check it out? See, you just, sir, just not see from the front, see from here at some angle. But you will observe here at this side, na. Just wait. See, if you just check it from here, on this yellow stick, you will be able to see like this orange one mixed here. Just check it from here at this angle, because refraction is there, na?
ஆரஞ்சு வந்து எல்லோட கலந்துருக்காங்க.
Orange and yellow comes in a straight line. So this is refraction actually.
Orange yellow mallet.
Yeah. Means inside this glass slab, na, here it's yellow. Here also same thing happen. Just check it out.
இங்க இருந்து பாருங்க. மேடா. போய்டும்.
Mohit.
ஆரஞ்சு வந்து கொஞ்சம் தள்ளி போகும்.
Now see from here angle. Upper side, na, upper side of this glass slab, yellow stick is there, but inside this glass slab, below this yellow, orange stick is there. So this is an example of refraction.
எல்லோவுக்கு அப்புறம் முன்னாடி ஆரஞ்சு இருக்கு.
Ma'am, wait. Now check from this angle.
அந்த ஆங்கிள் வச்சு தான் மேடம் கட்டது.
இந்த ஆங்கிள் நீங்க இங்க இருந்து
ஓகே. ஏ ஒரு பென்சில் மேல அந்த பென்சில்
Because na, what happens actually is,
அந்த ஆங்கிள்ஸ் மூலமா தான்
if this is a glass slab, see, if this is a glass slab, this is a incident ray, okay, then normal ray, then there is a bending of light in this way,
refraction ray.
in this way. So at some angle it refract. So here, if you will see from this angle, you will be able to see, like here it's a yellow stick, but inside this glass slab you need to see from here. So below this yellow, na, inside the glass slab, orange stick is there.
முன்னாடி
So this is a concept of refraction. Another example of refraction, we have given this laser optical tank. So what you will do here, half filled it with water, okay, then there is again two mediums. This is air, half filled water is water. So if you take the laser light from here, again refraction is there. So these three topics we given related to the refraction only.
The example.
Anamorph. So here in anamorph, what we have given, if you will be able to observe this image, this shows nothing. This shows nothing. In actual, this is a distorted image. Okay. Now there is one circle here. Na? If I put this metal piece here, you will be able to see a picture of a person here with a beard at some focal length.
கீழே வந்து அந்த ரிஃப்ளெக்ஷன் வந்து
Wait. So first of all, you see, you will be able to see a picture of a person. Just see here. Sir,
Oh,
see
face,
na?
face.
Sir, here it's a face, na? Here.
Okay, sir. Ama, sir.
Person with a beard.
Head, hair.
Everything is there, sir.
Okay, sir. Okay.
So this is an example of a distorted images and a complete image. I'll show you. Wait.
Man,
Ma'am, just
இதோ
see.
இங்க இருக்கு.
Ma'am, you just see at the bottom.
இங்க
Here.
இது நார்மல் பிக்சர் பட்
This is a distorted picture actually. So what happens here is actually this is a reflecting metals thing, na? This is a circular way. So in this circular way we expand this particular face in a distorted way, and now these particular distorted things gets the reflections at the surface, and in this circular na, they gets again undistorted. Then you will be able to see this image. So this is an example of anamorph. Yeah, no problem. To cover is that is a Newton's law. Okay. So there is a scientist who gives different laws, Newton. Okay. So he gives actually three laws. So here we are covering two laws as per the list. First is Newton's first law. So Newton's first law states that any object remains at a rest until or unless any external force is applied on it. Okay. When that means ki if any of the object is at rest, it remains at a rest until or unless we put a force on it. If any object is in motion, then it will become in a motion until or unless we didn't stop it. Yes, there are some friction forces which puts the opposite force actually. That friction force actually stops it, but yes, the object remains at a rest until or unless any external force is applied. So to explain this concept, how we explain this particular concept, we explain this with the help of this particular experiment. So dust is there on all the actually models. So from time to time, na sir, please ask your peons or anyone to put 15-20 minutes and very carefully clean all the material and all. Okay, so it will be great for the material also and for the students also. So how we are explaining this particular thing? See, this is a ball. Okay, this is a base. So I put this base here. So now this ball is here. So the task is as per the Newton's first law. But we need to do this ball. We need to take out this particular plastic plate, and we need to put this ball in this particular circle. How it's possible? So here Newton's first law applies. So what I will do? So what I did here is, with the help of this, I make this particular plastic piece in a motion. So this comes in a motion, and this ball remains at a rest because we don't put any motion over this particular ball. So this particular plastic plate is only in a motion. This remains at a rest. So that's why this remains at a same position. Okay, and Another important thing, whenever you ask the students to do this activity, okay, make sure that that much of stretching is enough. If students stretch it till this point, it breaks. So it all depends on your instructions actually, how they are going to use the material. So if we'll check it out, okay. So practically also now what happens is in our home, see, we to did definitely this thing. If there is a lot of the lot of things are there, if we want to take the thing which is at a bottom, so what we do is we hold that particular material and with very large force we take out this the thing. So we what means what we did is we only give the motion to that particular thing which we are pushing it, which we are pulling. So that particular object is in motion, rest of the complete things are at a rest. So we will be able to take the material out. This is practically happens actually. So in this way you will be able to explain them practically. So if you want to check it out, you just do this. Put your hand here, and then yes. This is a flat.
This is a flat shell on the bottom.
Hmm.
Got it.
Force நீங்க increase பண்ணணும்.
Force increase.
Force நீங்க increase பண்ணீங்கன்னா
हेलो सर, हाँ जी हाँ जी, मैं ये पूछ रहा था कि मैं अभी थोड़ी देर में इसकी पेमेंट कर दूँ या अभी करूँ पहले? मैं ना एक्चुअली ना चेन्नई हूँ, एक ट्रेनिंग में हूँ, फ्री होते ही इसी कर देता हूँ पेमेंट, बट आप इनको भेज देना प्लीज़ सर। ठीक है सर, ठीक है, ठीक है सर, ठीक है, ओके सर, ओके,
Another force call है.
ठीक है सर, ओके सर, ओके,
Plate
ठीक है
में
सर,
बटन force.
ओके, थैंक यू सर।
Another update.
So it's necessary now you also trained, only then you will be able to do it with the students.
kinetic energy and potential.
Sorry, first law.
So does every object needs a different type of force?
Yeah, to be in a motion. Yeah, because the thing is that now, if suppose if this ball it's here, so it will remain at rest. You need to push it with a force. It all depends on a force, means how much force you are pushing. It will attain that much of a distance. If you will put little bit force, it will go till that point. If you will make some more force, so it all depends on a force.
Object வந்து நான் receive செய்யணும் அப்படின்றாங்க. நான் கம்மியா force பண்ணா அதுக்கு ஏத்த மாதிரி அந்த object வரும்.
Less force, less distance it will cover. More force, more distance it will cover. Okay, this is Newton's first law. Then second thing we are giving is Newton's third law. So what Newton's third law states that every action has equal
First law. First law.
first law.
Object is in motion. How it
So if we applied force on it,
not force applied, continually motion.
yeah, no. That was I informed you earlier now. If suppose if this ball it's in motion on this particular surface, but this surface is also having a friction force. That friction force is a opposite force which applies to the motion. So that's why somewhere if you roll the ball, it stops at some point because some frictional force is also there. Frictional force insists that particular force to get lower down and stops the object.
No pressure force. Continually motion.
No contact. That's why na, see, if right now if we are walking, so we are able to stop because of a friction only. That's why if you will see na, in our footwears, in our shoes, they are having the that rough surface that the below, so that our shoes comes in a friction of the floor, so that we will be able to stop. In a vehicles also, suppose if you don't put any gear, if you just push the vehicle, okay, it goes at some distance, but yes, after covering some distance, if it's a equal surface, it stops somewhere because that floor or that earth or that particular road that is putting a opposite force to the tires. And what is that opposite force? That is a frictional force actually. Frictional force. If we don't have friction, if we are having a frictionless surface, then nobody will be able to stop actually. Then everything will be in a continuous motion. That is the main thing. Continuous motion, no one will be able to stop. That's why because of friction only, anything can be stopped because of friction. If no friction, nobody will be able to stop. Yeah. So this is Newton's third law. Newton's third law states that every action has equal and opposite reaction. Third law, third law. As per the list, there is no experiment related to second law. So although second law is the total force applied on an object is equals to its mass into the acceleration, means the force we applied, F equals to ma. So that is the second law. But in our list which we got, it's not object is there, no apparatus is there related to second law. So this is a third law. Yeah, big force. Yeah, force equals to its mass into its acceleration. Yeah. So Newton's third law is every action has equal and opposite reaction. That means you can take the practical example to teach it to the students. You just ask them, suppose if two friends are sitting on a table, okay, suppose they are continuously studying or just talking with each other, then nothing happens. But suppose if one of the child just slap on the mouth or the face of one of the child, then what happen? Then another child will slap with a more force. React. Why? Because with the action of a first child, means whatever was the action of first child, he slaps. So the second child reacts. Only then. See, if suppose, I'm just taking a normal example, suppose if we are sitting on a table, we are just talking, then it will go in a smooth way. We'll talk for 1 hour, 2 hours, 10 hours, 15 hours. But suppose if you start abusing me, then what happen? Then see, at some extent though, I'll just see ki, no problem, I'll just stop you, sir, please don't say these things. But then there is one level actually, then I also start abusing. So that means because of your action I am reacting. So that is a Newton's third law actually. Understand na? For every
Action, reaction, equal and opposite.
equal and opposite. Okay, so to explain that thing, how we explain that thing practically, so we have two cars here. Okay, so right now we push these cars towards each other. Okay, so see, it all depends on a force I am putting. If I put less force, it will exert less opposite force. See, right now I put this much of force, so it will go till this point. If I put more force this way, means the amount of force I am putting, the same amount of opposite force it's putting. So this is actually the equal and opposite reaction of Newton's third law. Okay, na? So this is an experiment. So with this we cover Newton's first law as well as the second law. Okay. So another is this one. See, although in our particular list now we are having only the solar model, but by giving only the solar model na, students will be able to understand about only solar. They are not able to see the differentiation. So we change that particular model to a 3-in-1 model, because in actual in a list na, which we got, there is only a solar model, but we change it with these 3 models. So how this particular model will work? So right now there is this node. Okay, this works on 3 mode right now. One is with power, means battery. one is solar mode, third one is generator also. Okay,
ஒன்னு வந்து
so
சார்ஜ், இன்னொன்னு வந்து சோலார் பேனல். அது எப்படி இருக்கும்னா, அது இது வந்து ஜெனரேட்டர், நம்ம பவர் சேமிச்சு வைக்கிறதுக்கு ரெடி
So-
பண்ணோம்ல அந்த
so-
இது பவரா.
so students will be able to understand the differentiation also. So first of all, I need to put this knob here, battery. Okay, so here we are giving three things. See, one is this light, sound, buzzer, motor. Okay, so see here, red stands for positive, black stands for negative. Here positive, here negative. So what I will do, I'll put here. So right now it said battery now, so it's on. So now I put the knob on solar. So right now, whenever there is solar light, means sunlight over the solar panel, only then it's open. So to make artificial solar light, what we will do, I'll put torch. See,
லைட்டா எரியும்.
see, light is on.
ஒன்னு வந்து பேட்டரி மூலமா யூஸ் பண்றது,
See.
இன்னொன்னு வந்து சோலார் எனர்ஜி மூலமா யூஸ் பண்றது.
So right now it's on because of this solar light. Okay. Another important thing, I put this knob over the generator. So right now, if I means right now it's not on because of battery not on. If I put light also, it is not on because right now it will work with the help of this generator.
ஜெனரேட்டர் ஃபர்ஸ்ட் வந்து சார்ஜ் மூலமா, செகண்ட் வந்து சோலார், தேர்ட் வந்து ஜெனரேட்டர். இங்க வந்து மோட் மாத்திட்டே இருக்கும். ஒரு மோட் இருக்கு.
Yes, these three modes:
Solar energy,
battery, solar cell, and dynamo. Dynamo means a generator.
generator.
So here you will be able to explain three different concepts. Okay, one is electric energy to electric energy, means conversion of energy also. Electric to electric, solar to electric, mechanical to electric. Mechanical to electric also. So you can also change this.
பேட்டரி மூலமா,
With battery,
பேட்டரி மூலமா
if solar is there, then it is on. Now, okay na? So means with the single apparatus, students will be able to understand 10-15 different concepts. First is how with the help of battery the light works, buzzer works, this motor works. So because this buzzer is of now very much value, so it is not able to work with this light.
இதுக்கு வந்து அவ்வளவா சூரிய வெளிச்சம் அதிகமா தேவைப்படுறதுனால
Yes, but if you will put it here na, this LED is on.
Light work.
அந்த ஒரு எலக்ட்ரிக்
See,
Work.
அதுக்கு தேவையான எலக்ட்ரிசிட்டி இருந்தா
because it depends on a current rating of this particular this component actually.
பேட்டரி
Now solar cell, when light falls with the help of generator.
இப்போ ஜெனரேட்டர் மூலமா வரும்.
And another important thing, see, motor na, motor works in both the directions. Okay, it is both direction, clockwise as well as anti-clockwise. So right now I am moving generator here, it is rotating this direction.
சோலார் வந்து அந்த பவர் நம்ம ரியலா
See, sir, in both the directions it's working.
ஜெனரேட்டர்ல வந்து நம்ம ஆன்டி கிளாக்வைஸ் அண்ட் கிளாக்வைஸா நம்ம ஃபேன் வந்து
Okay na?
அங்கேயே வேற
What are positive, negatives? What is buzzer? Means how it's making a sound. It's a piezoelectric thing. What is motor? How it's rotate? Anti-clockwise direction, clockwise direction. What is a fan? Then how the battery will work? How the solar will work? How generator will work? With the help of generator, clockwise and anti-clockwise, both you can work. Means in this way, now it all depends on you. Number of concepts you will be able to explain. And another important thing, like whenever you use this apparatus now, you explain these things, take it out. Cells also, take this out. Otherwise it will get discharged. Why it is red and why it is black? It's a universal rule which is followed over all over the world. Red stands for positive and black stands for negative. It's a universal rule which follows everywhere in the world. So in this way, with the help of this, you will be able to explain lots of concepts. Lots of concepts. Okay. This is a Newton disk actually. Okay. So what is a Newton disk? It shows a white light is comprises of 7 different colors. Vibgyor pattern. So practically what happens is, suppose if there is a dark room, okay, and if sunlight comes with some hole and where, so there also you will be able to see all the colors, dust particles as well as colors. If suppose after rain immediately the sunlight is there, then also you will be able to see a rainbow. That is also because of scattering of light. Okay, and here if I rotate this, you will be able to see the white color.
இது நம்ம எவ்வளவு ஃபாஸ்டா சுத்த சுத்த என்ன ஆகும்னா நமக்கு அந்த கலர் வந்து மறையும் சார். ஆனா ஒரு சைடுல மட்டும் நம்ம ரெட்
So
கலர் பார்க்க முடியும்.
So which shows a white light is made up of 7 colors. That is Vibgyor pattern. Vibgyor is this one, na? Violet, indigo, blue, green, yellow, orange, red. Okay. So you also ask the students, if you want to give some homework, ask them, take a circular sheet, make these type of divisions and do the 7 colors. And then if you rotate it, you will be able to see 7 colors. So in this way now you will be able to involve the students actually. Understand? So these are the important concepts. See, in class 8th or 7th or 9th, there is a chapter related to eye. Okay, eye related to chapter. So in that particular chapter, what we studied is, if we have any image, that image is having impact 1/16th of a second. 1/16th means any image, if we see image, so that image is having impact on our mind for 1/16th of a second. Okay, what does that mean? If in 1 second we passes more than 16 images from in front of our eyes, it will act as a video. Okay, you know our cameras, we say we are having 5 megapixel of camera, 10 megapixel, 20 megapixel. So you know what does that mean? That means, no, not image. Image capacity is okay. Suppose if there is image, mega means 10 ki power 6, 5 into 10 ki power 6 pixels actually. Pixels means one image is having that much small of a pixels. That means in this one image we are having
எத்தனை பிக்சல்ஸ் இருக்கோ அதுக்கு ஏத்த மாதிரி அந்த
that means we are having these small 50 lakhs of a pixels in one image only. More the number of pixels, more clarity is there in an image. Okay, so in ancient times, means right now so we are having a digital you can say theaters, that PVR cinemas are there and other things are there. But in ancient time what happens is, practically na, manually behind the screen there are people who take the photographs, big photographs. They take more than 16 images in 1 second in front of our eye. They manually roll it actually. So that's why we are able to see the videos actually. So this to explain the same concept, because right now it's not possible to develop those type of a theaters. So to explain that particular concept to the students, what we have done, we have developed these type of a things. See, right now there is a horse with different angles, different postures are there. Okay, so what we will do here, different posture images are there. Okay, you need to see from these holes, Okay, I rotate it, you will be able to see like this horse is running. See, horse is running. Why this happens? Because again, 1 by 16th of a second means in 1 second, more than 16 images passes on from in front of our eyes. So that's why these images will act as a video. That's why we understand that this horse is running actually. Okay, na? So if you will be able to see in this way, horse is running at a backside, and if I rotate it in this direction, see.
அந்த பிக்சருக்கு தேவையான நம்ம ஒரு போஸ் என்ன கொடுத்தோம்னா அந்த போஸ் மூலமா அந்த பிக்சர் வந்து ரன் ஆகிற மாதிரியே தெரியும்.
Okay, sir. So this is basically concept related to our eyes. Okay. So one more to explain the same concept more clearly. This topic is there in a books also. Bird in a cage activity. So there is a cage you see. Here it's a bird. So again, we rotate it in such a way so that in 1 second it rotates more than 16 times. So what you will feel कि this bird is inside its cage. We just cross check it. See. So what we observe is this bird is inside a cage. So it all depends on the number of images we see. If I rotate it in a slower way, right now, you are not able to. Sorry.
Some poses used.
Sorry.
Slow force used. The
Yeah.
pictures is not
Yeah, because now if I put lesser force in this way, in 1 second, more than 16 images are not passing from in front of my eyes. That's why these images will act as a separate ones. See. But yes, now more than 16 images. Right now, this bird is in a cage. So this is a again example of a ice. Okay. Next topic is another important topic is buoyancy, buoyance force. So see there we are having a very bigger size of a ships na. So how these ships will be able to float on a surface? Because of a buoyance force or a upward force. Okay, to explain this concept, what you will do, take a needle, okay, put it in a water, it will sink. Okay, sink and float concept. And do one thing, take a foil paper this much square size and put it over a water. So what happens is that particular foil paper will float on a surface. Why? Because the foil paper is of that much of size. Okay, so and needle is like this one.
அந்த டென்சிட்டி பொறுத்து அந்த பிரஷர் இன்க்ரீஸ் ஆகும்.
Okay, so here more upward force exerts. That's why this particular foil paper will be able to float. But in this needle, only at this pinpoint one force is there. So that's why this needle sinks. To explain this concept, we are having two models here. One is floating a ball experiment and another is floating a fan experiment. So what happens actually here is, I'll show you. We have put one ball here, thermocol ball, it's removable ball. Okay, and there is a fan. Okay, so fan puts a pressure over this particular thing. So fan is putting more pressure and this ball is lighter in weight. So once the more pressure object is putting a upward force, this lighter object will float. So we will check it out. See, I on this particular, the ball is there. Okay, right now if I off, this ball is at a bottom. Now if I on this, this is putting the upward force and this ball starts moving upward size. See, so that much force exerts on it. See, so it's floating here. This is a concept of actually a buoyancy force. If I off it, it goes down. Okay, so one experiment is this one and another experiment is this one. Same happens here also, this fan will float in here. Okay, so here the concept of actually a buoyancy is there. Buoyancy means a upward force which is putting the more pressure on a lighter object actually. Okay, so this is example of buoyance force. So right now it's a windmill. So windmill means, you see, when there is a deserts or there are mountains, so there we use the windmill. So what actually is a windmill? Windmill means we convert the air energy into some useful energy, either into a electric energy, either into a mechanical energy, anyway. So here what we will do, we are having this knob. Okay, so with the help of this windmill, we store this energy in a motor. Means with the help of this windmill, we rotates the dynamo. Okay, then it will generate the electricity here. See, there is a knob. This knob is there. We are having one voltmeter here, 0 to 300 volt. If I rotate this, so this voltmeter is having a deflection. That means it is creating a voltage actually. Okay.
அதாவது நம்ம காத்து இருக்குல்ல சார், காத்துல இருந்து இப்ப நம்ம சுத்தும் போது ஒரு எனர்ஜி உருவாகுது. இந்த எனர்ஜி வந்து இப்போ என்னவா கனெக்ட் ஆகுதுன்னா எலக்ட்ரிசிட்டியா கனெக்ட் ஆகுது.
Means the speed of rotation depends at how much of voltage it is generating right now. So I am rotating it, it is having this type of a voltage generation. So that means a wind energy is changes into a electrical energy. So at deserts, at mountains, what happens is, with the help of windmill, lots of works the people will do. Sometimes with the help of windmill, they make the, means the floor machine they make, so that they will just that make the that wheat changes into a you can say the floor. Sometimes they rotate one motor to took the water upside, that also they will do to generate the electricity. They use this type of a windmill. So windmill is having a multifunctional work actually. Okay, so this is a concept of a windmill.